All right, today we're going to pull back the curtain on some of the invisible magic that powers our entire digital world. We're talking about distributed systems. It's the secret sauce that makes all your favorite apps feel so instant and so reliable. We're about to find out exactly how it all works. So, let me just ask you a question. What could an app like Netflix or TikTok and your local coffee shop, what could they possibly have in common? Well, the answer is kind of surprising. They both have to survive the morning rush. They have to serve this massive, sudden crowd of customers without breaking a sweat and without ever failing. Let's stick with this coffee shop idea for a minute. Just imagine the busiest cafe in town, right? It's facing two huge, constant problems. First, how do you serve hundreds of people who need their coffee right now, all at once? And second, what on earth do you do if your main espresso machine suddenly just breaks down in the middle of all that chaos? Now, those exact two challenges are what every single popular app on your phone deals with, just on a much bigger scale. They've got to handle millions of us clicking, scrolling, and posting all at the same time, and they absolutely cannot afford to go offline. This right here is the core problem of system design.
Okay, so how does our coffee shop deal with that insane morning rush? Well, it uses two key strategies. And these are the exact same strategies that power the biggest apps in the world. They're called concurrency and parallelism.
First up is concurrency. So picture one incredibly efficient barista. They take your order, they start steaming milk for it, but while that milk is steaming, they're already taking the next person's order. And then, while that person's espresso is pulling, they're finishing up your drink. See what they're doing? They're making progress on multiple tasks, switching between them super intelligently. They're managing many things at once. And this little story perfectly illustrates the technical definition. Concurrency is really just the ability to manage multiple tasks by making progress on them together. You don't necessarily have to finish one before you start another. It's all about structuring your work so you can handle a lot of things at once, even if you have limited resources.
But what happens when one barista just isn't enough to handle that line stretching out the door? Easy. You hire a second one. Now you have two baristas working side by side, and they're each making a full cup of coffee at the exact same time. You've literally just doubled your output. You're not just managing multiple tasks anymore, you're doing multiple tasks at the same time. And that is parallelism.
And the technical definition here is very precise. Parallelism is the simultaneous execution of computations. And this requires the hardware to back it up. You need multiple processors, or in our analogy, multiple baristas, all working at the very same instant. So the crucial point to remember is this. Concurrency is about structure. It's about dealing with many things at once. Parallelism is about execution. It's about doing many things at once. You can be concurrent without being parallel, like our single-skilled barista, but you can't really be parallel without the ability to be concurrent. Okay, so we've kind of figured out how to handle the rush. But what about that second coffee shop problem? The one we all dread. What happens when, right in the middle of that huge rush, the coffee machine breaks? It's a total catastrophe, right? No coffee, angry customers, a line out the door. The entire operation has what we call a single point of failure. When that one critical component goes down, everything just stops. Dead. Now, in the digital world, this kind of thing happens constantly. Servers crash, networks fail, databases go offline. These are the coffee machines of the internet. And so the real goal of a well-designed system is to be fault-tolerant, to be built so that when one piece inevitably fails, you, the user, never even notice it happened. So what this means is you can't just hope for the best. You have to actively design for failure. You have to build a system that expects things to break and knows exactly what to do when they do. So how do we build a coffee shop or an app that can survive a broken machine? To do this, engineers rely on a set of core principles. Things like replication, which means keeping multiple copies of important data, redundancy, which is having backup components ready to go, there's load balancing, which spreads traffic out so no single server gets overwhelmed, failover mechanisms automatically switch to a backup if something breaks, and graceful degradation, which means the app might lose a non-essential feature, but it won't crash entirely. If we map this back to our coffee shop, it's actually pretty simple. Redundancy just means having a backup espresso machine plugged in and ready to go the moment the first one fails. And replication? That's like having a perfect copy of your unique, award-winning coffee bean recipe stored somewhere super safe so it can never be lost. It's all about getting rid of those single points of failure. So we've talked about baristas and coffee machines, concurrency and redundancy, but why does any of this actually matter to you when you're just, scrolling through your phone?
It matters because this is the invisible magic that makes modern technology feel so seamless. The only reason your favorite apps feel fast and responsive and are always available is because armies of engineers have built them using these exact principles. They're designed from the ground up to handle both the massive rush of global users and the inevitable breakdowns that happen behind the scenes.
But, and this is a really big but, none of this comes for free. Building systems that are this fast and this resilient involves making some incredibly difficult choices. And, like this quote says, everything in system design is a trade-off. You often have to choose between competing priorities.
Which leads us to our final thought. Imagine you had to choose for your favorite app. Would you rather it was always available, even if sometimes the data might be slightly out of date for just a few seconds? That's called availability. Or would you prefer the data to be perfectly consistent, every single time, even if it means the app might be unavailable for just a moment during an update? That's consistency. It's one of the biggest, most fundamental trade-offs in all of system design. So, which one would you choose?